Hi guys, welcome to the Instructive Academy. So in the last video we had studied about the fundamentals of force, the definition of it and few day-to-day life examples that we experience. In this video we are going to go a little further into the chapter and we are going to study contact and non-contact forces. So force, there are two types of forces, contact force and non-contact forces. Coming to the contact forces. So contact forces are those which are produced and experienced when the body comes in contact with another body. So if I tell you the perfect definition, it goes like the forces which act on the bodies when they are in physical contact. So I'll give you examples of contact forces. First one, frictional force. Second, normal reaction force. Third, force exerted by a string. Fourth, force exerted by a spring. And the fifth one, force due to collision. Coming to the non-contact forces. So obviously, what do you mean by non-contact forces? The forces which are experienced when the bodies are not in contact. Even if the bodies are not in contact, they experience this kind of a force called non-contact force. So if I go to write the definition, the force experienced by bodies even without being physically touched. So the examples for non-contact forces are the gravitational force, electrostatic force, and the magnetic force. Now we are going to study each examples in details. So stay tuned. Starting with the frictional force. So what does that say? When a body slides over a rough surface, a force starts acting on the body in the direction opposite to the motion of the body along the surface of contact. This is called as a frictional force. So for example, if we have a block kept on the table which has a rough surface, and if we push the block to suppose the right side, if we push the block to the right side with force F, so at the same time there is a force which is acted in the opposite direction which restricts the motion of the block. This force is known as the frictional force. This force restricts the motion of the block. So I hope you've got what frictional force means. Next we'll go to the force called the normal reaction force. So what does a normal reaction force say? Supposing if there is a body which is kept on the surface, this body exerts a force which is equivalent to its weight. But at the same time, there is an equal and opposite force which is exerted by the surface and which is normal to the surface. This particular force is known as the normal reaction force. Due to this normal reaction force, the block which is kept on the table does not move and it stays in position. Coming to the third example, tension force is applied through a string. So what does that say? So when a body is suspended by a string, the body, suppose if there is a string, and the body is suspended, so the body will move downwards because of its weight, and this pulls the string vertically downwards, and the string in its stretched condition pulls the body upwards by a force which balances the weight of the body. This force developed in the string is known as the tension force, denoted by T. So for example, if when the body is suspended and you just cut the string from above, the string will move upwards with a jerk, showing that there was some tension which was present in the string due to the body. Now coming to the fourth example, force exerted by a spring. Now in this case, if I have a spring which is in its loose condition and there are two bodies which are attached at each end of the spring. This is in its loose condition. Now if I compress the string, the same string, if I compress the strings, both the body A and B will try to move far away from each other with a force F. This is case 1. And case 2, if the same string is stretched, then the two bodies will tend to come closer to each other with a force F. In either cases, the spring has a tendency to come back to its original form and it has a force F. This force F is known as the restoring force. So this was all about the force exerted by a spring. Now coming to the force exerted during collision. So the force exerted during collision, what does that say? It says when two bodies are collided, they push each other after collision or they move apart after collision. So suppose if I have a body B which is moving, and I have a body A which is also moving. If the body B collides with another moving body A, the body B exerts a force AB on body A. So when they collide, like during collision, suppose this is body B and this is body A. The body B exerts a force FAB on body A. This FAB force is the action force, and it is the force on A due to body B. Now at the same time, there is an equal and opposite force known as the reaction force, which is exerted by body A on body B, which is called as FAB. So FBA, which is it's FBA, which is the reaction force, and that's the force on body B due to A. That's actually an equal and opposite force. So as a result of these forces, the two bodies after collision, they move apart because of these forces FAB and FBA. Because of these forces after collision, both the bodies move apart. So this was all about the forces exerted during collision.